beneath the ocean's surface. An ancient conversation hums in rapid clicks. Messages pass between giants with brains 6 times our own. Today we're diving into how artificial intelligence cracked the code of whale communication, revealing a language so complex it rivals our own. The team of scientists was preparing for the main experiment. If we understood the structure of their language, could we not only listen but also speak? The first attempts at two-way communication began in 2023, and what happened next shocked the entire scientific community. The whale SETI team studied humpback whales off the coast of Alaska. Using an underwater loudspeaker, they played a recorded contact signal from a humpback whale. The response was immediate and amazing. A female humpback whale named Twain swam towards the boat and began circling it, responding to every signal. The conversation lasted 20 minutes, a real exchange of phrases between a human and a whale. Twain accurately copied the breaks between the signs, adhering to the rules of conversation like a polite participant in dialogue. This discovery surprised the entire SETI project team. In the same year, 2023, they conducted their own experiments off the coast of Dominica. A diver, using an underwater loudspeaker, played one of the sperm whale codas they were studying. A nearby whale responded with similar sounds. This was followed by another exchange of signals. It was a humbling but historic moment, the first attempt to communicate with a sperm whale in its own language. But here's what makes this even more incredible. The whale didn't just respond randomly. It matched the timing, the rhythm, and even the emotional tone of the human-initiated call. This wasn't a coincidence. This was proof that whales understand the structure of conversation, that they have rules for communication just like we do. The implications were staggering. We weren't just listening to animal sounds anymore. We were witnessing the first steps toward genuine interspecies dialogue. In 2017, a meeting at Harvard University set a new course in science. Marine biologist David Gruber was studying sperm whale recordings when cryptographer Shafi Goldwasser overheard the sounds. To her, the clicks resembled Morse code, and she wondered if they might be a structured form of communication. She proposed applying machine learning, and soon connected Gruber with David Michael Bronstein, an Oxford AI specialist working on early large-scale language models. Bronstein explained the critical requirement, vast amounts of data. And to decode whale communication, billions of recordings with context would be needed. What seemed impossible began to look achievable. Unlike human languages, whale communication had no dictionaries, grammar, or speakers to consult. The recordings sounded like random clicks. The breakthrough idea was not to translate immediately, but to map the structure first, identifying grammar and rules before meaning. In 2019, Gruber, Goldwasser, and Bronstein reconvened at Harvard for a 2-day symposium. Biologists, linguists, roboticists, and AI experts from around the world attended. By the end, consensus emerged. Decoding sperm whale communication was within reach. The tools existed, the methodology was rigorous, and the potential insights were extraordinary. This led to the founding of the Cetacean Translation Initiative in 2020. With $33 million in funding from TED Audacious for 5 years of research, the project united 50 leading scientists from 15 global institutions, including MIT, Harvard, Oxford, Berkeley, and the National Geographic Society. Gruber assembled a multidisciplinary team that brought together expertise in artificial intelligence, marine biology, linguistics, and robotics. The results exceeded all expectations. What we once thought were random clicking sounds have turned into a highly organized communication system that rivals human language in its complexity. Sperm whales use codas, short rhythmic clicking sequences that function like words in human language. Each coda consists of a specific number of clicks with precise time intervals between them. For example, a common coda among Caribbean sperm whales is 1 + 1 + 3, 1 click, pause, another click, pause, then 3 quick clicks in a row. But here's where it gets truly fascinating. In May 2024, the SETI project team published a groundbreaking study in the journal Nature Communications. By analyzing 8,719 recorded codas off the coast of Dominica, AI identified 156 distinct basic patterns. But that was just the beginning. Each coda can vary in several parameters, creating a huge number of unique words, and the system is far more sophisticated than anyone imagined. The first level is speed. The same coda can be delivered slowly or quickly, changing its meaning accordingly, just like how we might speak slowly to emphasize importance or quickly to show excitement. The second level involves additional click sounds at the beginning or end, similar to prefixes and suffixes in our words. These ornamentations can completely alter the meaning of a basic coda. The third level turned out to be the most surprising. Whales can lengthen or shorten the pauses between clicks slightly, just as we change the pitch of our voice to express emotion. This rubato, as scientists call it, allows whales to convey subtle emotional information within their communication. The fourth level involves subtle time differences that function as vowels in human speech. Whales use these precise timing variations to transmit different types of information within the same basic coda structure. They chose the Caribbean island of Dominica to experiment, and the location is absolutely perfect for this groundbreaking research. The volcanic cliffs drop so steeply into the sea that the deep ocean begins just a few hundred meters from the coast. This means sperm whales can come very close to land, making them accessible for observation in ways that would be impossible in most other locations. Most importantly, the same families return year after year, allowing scientists to study generational communication patterns. The team transformed a stretch of ocean near Dominica into a massive underwater recording studio. A system of dozens of hydrophones operates around the clock, creating a real-time acoustic map of the area. When a sperm whale makes a series of clicks, the system immediately determines which whale in the group is talking, where they are positioned, and who they might be communicating with. It's like having a sophisticated surveillance network that can track conversations across miles of ocean. But audio recordings are only one part of the puzzle. To understand a language, we need context. Who is speaking to whom, in what situation, and what emotions are involved. This is where cutting-edge robotics comes into play. The SETI project has developed a fleet of autonomous drones that track whales and carefully attach biosensor tags to their backs without disturbing their natural behavior. The team studied how marine animals naturally attach in the wild and developed biologically inspired appendages so sensitive that whales barely notice them. These tags are technological marvels that go far beyond simple recording devices. Not only do they record sounds with incredible clarity, but they also capture the whale's three-dimensional movements, dive depth, heart rate, and precise information about other animals they are currently interacting with. Each tag can last up to 3 days, providing an unprecedented window into whale social dynamics. The data collection process is staggering in its scope. Every day, the system captures thousands of individual whale vocalizations, each one tagged with precise location data, behavioral context, and social information. The researchers know which whale is the mother, which are the juveniles, which whales are related, and how their relationships affect their communication patterns. It's like having a complete social media feed for an entire whale community. And before we continue unfolding this fascinating discovery, be sure to subscribe and hit the bell so you don't miss any future episodes. Don't forget to share it with your friends, too. It helps the channel out, and I'm excited to continue bringing you more awesome content. To the human ear, the deep ocean is only a confusing jumble of clicks, grunts, whistles, and waves. Trying to find a particular pattern from all this noise is nearly impossible for human researchers. The first biggest challenge for the Project SETI team was to turn all the raw audio they collected into something the AI could actually interpret and analyze systematically. They used a process called spectrogram analysis that transforms sound waves into visual charts. With this technology, they could take something as complex as whale vocalizations and turn them into detailed visual patterns that reveal hidden structures. The AI could now visually see the whale sounds, identifying subtle patterns that would be completely invisible to human researchers even after years of study. The AI's first task was to sort through these visual representations and identify the codas, which are the specific sequences of clicks sperm whales use to communicate, while filtering out all the background noise of the ocean. This initial process of turning invisible sound into visible patterns was the crucial first step that made everything else possible. This is where the power of machine learning became truly revolutionary, acting as a modern-day Rosetta Stone for interspecies communication. The team used advanced AI technologies, including deep learning and neural networks, which are designed to learn patterns the way humans do, but at an incredibly accelerated pace and with perfect memory. The AI wasn't given a predetermined list of rules about how whales communicate. Instead, it was trained using millions of whale codas, learning to recognize patterns through pure observation and analysis. By studying these massive data sets, the system slowly started to find patterns on its own, identifying which sounds often appeared together, how they changed in different social situations, and what contextual factors influenced their usage. The AI began to notice tiny differences in the clicks that were completely unnoticeable to human listeners. It could detect subtle variations in rhythm, tempo, and timing that our brains simply couldn't process. The computer was learning whale language the same way a child learns human language, but much faster and with access to a data set that no single human could analyze in multiple lifetimes. The sheer scale of the data, over millions of vocalizations collected over many years, gave the AI the statistical power to find these hidden patterns. Without this massive data set, the AI would have been as limited as human biologists in understanding whale communication. The most surprising findings relate to cultural differences that mirror human societies in remarkable ways. Different sperm whale clans, their extended family groups, use different dialects. These aren't just different symbols, but different ways of applying the same basic communication rules. The team discovered that clans with overlapping territories adopt elements of each other's speech patterns, providing the first evidence of social language learning in marine mammals. This cultural exchange happens gradually over generations. Young whales learn not only from their immediate family but also pick up communication patterns from neighboring clans they encounter during their travels. It's exactly like how human children might develop accents that blend their family's speech patterns with those of their broader community. The AI has also learned to identify the individual acoustic fingerprints of specific whales. Each whale has a unique voice signature, small but consistent variations in timing and rhythm that allow researchers to identify them among hundreds of other whales in the area. Imagine being able to distinguish a particular whale's voice as easily as you can recognize a friend's voice on the phone, even in a crowded room. The system can track how a whale's vocalizations change with age, documenting what new communication elements they adopt from their family and social group over time. Researchers have observed young whales gradually incorporating more complex codas into their repertoire as they mature, suggesting a learning process that extends well into adulthood. Even more fascinating, the AI revealed that whales have signature calls, unique acoustic identities that function like names in human society. These signature calls are used when whales want to get the attention of specific individuals in their group, allowing for targeted communication within larger social gatherings. For decades, scientists assumed that if whales had language, it would be simple and direct, focused on basic survival needs like finding food, avoiding predators, or coordinating group movements. The AI revealed something completely different and far more sophisticated than anyone had imagined. The patterns the computer discovered weren't tied to simple survival actions but to complex social contexts. Whales communicate about relationships, family dynamics, social hierarchies, and cultural traditions. Their language reflects the intricate social lives of creatures that live in multi-generational family groups with complex alliances and relationships. As the AI continued analyzing the data, it uncovered an even more astonishing level of linguistic sophistication. Within the clicks, there were subtle variations that acted much like vowels in human language. The whales use a sophisticated system of rubato, fine-grained changes in rhythm and timing that can completely alter the meaning of a basic coda. These timing variations aren't random. They follow consistent patterns that suggest grammatical rules as complex as those found in human languages. A whale's coda might have a specific basic meaning, but a slight pause or quickening of tempo could transform it into a question, an emphasis, or an emotional expression. The ornamentations, extra clicks added to the beginning or end of codas function like grammatical markers that provide context and modify meaning. It's as if the basic words are being sculpted and shaped to express different intentions, emotions, and social relationships. For decades, humans could only listen to whales, like overhearing conversations in a language we couldn't decode. Thanks to advances in AI, researchers can now map the structure of their communication. This breakthrough marks the start of a bold new phase for Project SETI, moving from passive listening to active participation in whale conversations. The aim is no longer just to decode. The team is working toward what once sounded like science fiction, a real-time communication system, sometimes described as an underwater chatbot. This isn't about teaching whales English or forcing them to adapt to human methods. Instead, it uses AI-discovered patterns to generate messages in their own language. Specialized underwater speakers transmit specific click sequences in the hope of sparking exchanges with wild whales. Early efforts focus on simple interactions, such as greetings or questions about environmental conditions before attempting deeper conversations about whale culture, social bonds, or perspectives on the ocean. Such ambitions raise profound ethical questions. Bridging two species requires careful thought about what flows across that bridge. Should humans initiate dialogue, and what obligations come with it? Could human involvement disrupt whale social structures, or even influence the evolution of their language? Since language is tied to culture, these risks are significant. Project SETI addresses them by committing to communication on the whales' terms, in their own language and at their own pace. Despite the challenges, the team has already reached a milestone. In 2023, a diver used a specialized underwater speaker to play a sperm whale coda that AI identified as a common greeting. The response was immediate. A nearby whale replied with the same coda, and a back-and-forth exchange unfolded over several minutes. This was not a simple playback experiment. It was a direct interaction, a moment of mutual recognition between two intelligences. The whale appeared to understand that the human-generated signal was an authentic attempt at communication and answered according to established whale social protocols. Project SETI is opening an entirely new frontier in biological research and our understanding of intelligence. For centuries, studies of marine life and animal cognition were limited to external observation, tracking movements, documenting behaviors, and analyzing social patterns. What remained inaccessible was the whale's inner world of thoughts, emotions, and cultural knowledge. With AI acting as a kind of translator, researchers can now probe dimensions of whale society once thought unreachable. This work goes far beyond physical traits or feeding behaviors. It offers access to the cognitive structures of whale communities, their relationships, traditions, and collective intelligence. The discovery is reshaping how we view animal communication, revealing levels of complexity that challenge long-held assumptions about intelligence and consciousness. Its implications reach beyond marine biology, touching cognitive science, linguistics, and philosophy of mind. One of the most striking connections is to space exploration and the search for extraterrestrial intelligence. SETI's name deliberately echoes SETI, the long-running effort to detect alien signals. For decades, scientists have scanned the skies for radio transmissions, but perhaps we have been expecting the wrong type of message. The methods developed to decode whale communication, using AI to uncover structure in unfamiliar signals, could provide the very framework needed if humanity ever encounters alien languages. These principles are universal. If another species communicates in a system unlike anything humans know, the strategies pioneered by SETI offer a roadmap for deciphering it. At the same time, the project grounds us on Earth with profound consequences. Understanding whale language fosters empathy and challenges the view of whales as distant or fundamentally different. Once their communications can be understood, about family bonds, cultural traditions, or their ocean environment, they are recognized as beings with emotions, intelligence, and histories passed across generations. This recognition strengthens the case for conservation. Whales shift from symbols of preservation to partners in communication, making their survival inseparable from the health of marine ecosystems. It provides powerful, scientifically grounded reasons to protect the oceans and confront climate change to safeguard the habitats of these intelligent beings. The discovery of whale language complexity might seem like the end of the story, But it's actually just the beginning of a much larger scientific revolution. The work of Project SETI opens up entirely new ways to understand our planet and our role as one intelligent species among many others sharing the same environment. The team isn't slowing down their research efforts. There are already ambitious plans in place to expand their work to other whale species, including orcas, humpback whales, and pilot whales. Each species likely has its own unique communication system, and understanding these different languages could reveal how intelligence and culture evolve differently in various marine environments. The researchers are also refining their AI algorithms with new machine learning techniques that could make the translation process even more accurate and comprehensive. Future versions of the system might be able to understand not just the structure of whale language, but also the emotional content, cultural references, and individual personality traits expressed in their communication. This effort is part of a growing global movement, where scientists are using artificial intelligence to study animal communication across many different species. Similar projects are beginning to decode the languages of elephants, dolphins, primates, and even some bird species, revealing a world of complex communication that we never knew existed. The ultimate goal extends far beyond scientific curiosity. This research is about building bridges between our species and others, creating the foundation for a shared future on a shared planet. The whales have important information to share about the health of the oceans, the effects of climate change, and the complex ecosystems that support all marine life. We are finally learning how to listen to voices that have been trying to communicate with us for millions of years. The conversation is just beginning, and the implications for science, conservation, and our understanding of intelligence itself are absolutely revolutionary. So what are your thoughts on this groundbreaking research? Do you think communicating with whales represents a crucial step forward for humanity? Or do you have concerns about what this kind of interspecies dialogue might mean for the future? Let us know your perspective in the comments below, and don't forget to subscribe for more incredible stories about the intersection of technology and the natural world. Thank you so much for watching, and we'll see you in the next video. Thanks for being with us. Leave a comment, like to show your support, and remember to hit that subscribe button for more exciting videos. See you next time.